This is Lab 3, Motion of a Black Hole. The purpose of this lab is to examine the effects of gravity's parallel and perpendicular components on the circular motion of objects. We will model these effects first on a star orbiting a black hole to determine the mass of the black hole, and secondly on a ship trying to escape off of that same planet. To begin principles-wise, our net force in this case is equal to the force of gravity, and the direction of that force is the same as the force of gravity on the star. So in that case, our force of gravity is equal to our change in momentum. We can rearrange our gravity equation to solve for the mass of our object. So given our F net is equal to change in momentum, we can use the derivative form of that change in momentum. And given that our momentum is equal to direction of momentum times magnitude of momentum, we can use the product rule to separate those terms out, equal to change in magnitude times direction of momentum as our parallel component, and change in direction times magnitude as our perpendicular component. And conceptually, that just means that we can only change the amount of momentum in terms of magnitude if it is in the same direction as the motion itself. And so for coding, and after coding momentum and change momentum, we can set F net equal to change momentum and then solve for perpendicular and parallel components respectively, and then use those components to get our F net and rearrange for our mass of our black hole. And I personally chose to create an array of all of those masses for each iteration and then get an average of that at the very end. So this is what my mass ended up being. And so for our second coding model, we bring back that mass we had from the first model that we solved for, and then using a given planet speed, we go and solve for all of the component forces acting on every object in the system respectively. And so using our gravitational formula, we're able to get those forces and then get the net force on our ship, and then from there, using trial and error, we can solve for the respective escape velocity needed to escape the system. And so what does net force and change momentum mean in this case? Our momentum is only measurable by the velocity of the objects and the force of gravity, respectively. And so orbitally, we can see that the speed of our objects can only be changed in the direction of its motion, and the direction can only be changed perpendicular to that motion using the force of gravity. Through more trial and error, we're able to determine a lesser velocity that allows the ship to go into orbit without escaping the system. Sources for error include lack of precision during our trials when it comes to finding our optimal velocities, as well as the fact that we are making all sorts of assumptions about our masses, as well as excluding other forces that would be in our surroundings that would affect this otherwise ideal system.